Hello, everybody. I am Daniela from ICLEI, from the THERMOS projects. Together with some of my colleagues, we are here to start the last session of our Train the Trainers THERMOS certification program, Pathway D. Thank you very much for your time, effort, and collaboration during these very intense weeks of work with THERMOS. We hope you have enjoyed it. And especially that now you will be our face to the world to use THERMOS in different cities and countries around the world. Please, we are going to start now. As you can see here, the agenda. We can put the agenda, please. So for today, we are going to have a very condensated agenda. Hopefully, we will make it everything in 1 hour. Just one thing that is important for you to know is that today, if it's okay with all of you, we are going to record the session. So please, if you have any constraint or you would like not to be recorded, please, if you can put that in the chat, so we can be careful of sharing any image or anything from you in this recording. On the other side, please also, if you have any question or any concern, we will always have the chat where you can put any of the information. Okay. So as I said before, thank you very much. So the agenda for today, it's projected or not anymore? Can you see the agenda?
Not at the moment.
Ah, yeah, okay. I don't know, I was able to present, but just 1 minute. Apologies for this. Now, can you see it?
Yes.
Yes, okay, good. So the agenda for today, as I said before, is we are going to start with a short summary of the program, of the experience that we have had during these 2 weeks, and then we will be very lucky to have 2 of our trainers presenting the cases that they have developed together with us. And then we are going to have a award ceremony to award you for your effort. And we are going to close the session with some next steps together, and we would like also to gather the feedback on your experience on the THERMOS Train the Trainers program. So with that said, and also is that Alex has some trouble in connection at her place, but hopefully she will join with voice again. But we are going to start now formally the process. We are going to start the recording already, so please remember to turn off the camera if you don't want to be included in the video. Thank you very much. So that said, I would like to give the floor to Julen, our officer on ICLEI, to talk about the program itself. Julen, floor is yours.
Thank you, Daniela. Hi, thank you everyone for attending our very last Train the Trainers webinar. We are so glad that you made it already until here and that you could attend this closing webinar. So as she said, I'm gonna give a little summary and an overview of this journey that has been the THERMOS Train the Trainers program. As you might have known, this was the last program of a series of 4 different training programs. So we have already been about 2 years doing this kind of programs, and yeah, we are sad but also very glad that we made it until here and the process is coming to an end now. So as you already know, the THERMOS Train the Training program aims to leverage the use of the THERMOS tool, which is an open source energy and climate action planning software. And the objective is to accelerate cities' transition to low carbon district energy networks for both heating and cooling, as you already know. And now I would like to give you an overview of what we already have done. So as you already know, this program was divided into 3 different sections. The first was some webinars like the ones you are attending right now. So it all started the 29th of October with the kickoff. Then we had a second webinar on the 12th of November about embedding THERMOS in university. And now we had finally our final webinar today. So we hope that you could attend to all of or most of these webinars. And now we can say with this smiley face that this part is completed. Also, you had two options for doing the training. The ones that most of you selected was the option A, completing the 3 exercises. And we already received your exercises. Thank you for your hard work. So we are getting another smiley face here because this is completed. And finally, the option B, which was selected by a few of you, was developing a case study with THERMOS. So this also came to an end already. So we can say that finally our Train the Trainers program, it's finished and it's complete with this final webinar. And now, so that you can see a bit the numbers on the results of the program overall. Well, before, of course, you're getting a certificate for completing the program. So congratulations for that. We will talk about that later. And now, as said, I would like to show this graphic you can see here with the numbers of all the different trainings we had in these past 2 years.
Julian, excuse me, we have a problem. Some of us, we cannot see the slides. Can you please try to project again?
Okay, are you seeing it now?
Now, yes, if you go, yeah, now we see it.
Okay, sorry, for some reason it went out. Okay, so as I was saying, in this graphic here, you can see a summary of all the training programs that we have had in the past 2 years. So we started with the Pathway A, which was only exercises, but no case studies, and we could certify 17 people there. Then in the Pathway C, and sorry, in the Pathway B, we introduced the case studies and we had more people here, almost double. So we certified 31 people and we had 5 case studies developed. Then in Pathway C, we only had six certified people and 2 case studies, but there is a reason for this. As you can see here, the reason was the COVID. Due to the COVID outbreak, which came as a surprise for everybody, many people were not working in the places they were or had time constraints, and well, they just couldn't complete the program, which it was understandable. It came as a surprise to everyone. But then with the Pathway D we just had, we got the best numbers in certified people, in total 39. So we are very glad of that. And adding to all of these trainings, some on-site separate trainings that were held, we had another 46 certified people. So we can say that thanks to the THERMOS training programs, we have certified almost 140 people that are already qualified to use the THERMOS tool perfectly. So we are very glad of this. Now that you have seen these numbers and you have a bit an overview of the training program, I would like to give the floor again to Alexandra. Alex? Or Daniela.
That's right. Can you hear me?
Yeah, now we hear you. Hi.
Hey, I'm back.
Great.
So my apologies for the unknown complications. I am the ghost in the machine. Thank you, Julian, for presenting the numbers. Like you said, we're really happy about all the great engagement with you. And having said that, I'm very happy to give the word to 2 of our outstanding trainers. The first one is Luis. I hope I pronounced it correctly. He was a trainer in our previous program. And he's exceptionally committed because he also did a training with our partner city Cascais. So he's really a renowned expert. Please tell us more, Luis, about your case.
Hi, good afternoon to all. It's my pleasure to be here and try to represent Cascais and the case study that I developed in the previous Train the Trainer section and workshop from THERMOS. And again, thank you for the invitation. I will try to present my let me. I don't know if I'm allowed to present my screen.
I think you should be.
Okay. Okay, I will show you my screen. Okay. Can you just check if you
Yes.
are?
We can see it.
Okay, so I'm here to present the case study for Cascais for Portugal. This was, like I was saying, was developed in the previous training pathway. So besides everything that you already or should already know about THERMOS, so is free web-based software to design optimize district energy network planning processes. And besides all the objectives that you already know, I think the key additional uses that the tool can support is to analyze key solutions for greenhouse gas emissions and also air pollutants emissions solutions, reduction solutions for the city and regarding the heating and cooling supply. It also helps you to identify in what concerns heating and cooling, improve local energy efficiency and also in buildings. And also really important is it can be used to analyze and how to reduce energy poverty in the municipality or in the city or the region that is under the cover of the network. And also more general objectives, it can increase and help to increase the local and decentralized renewable energy sources. And talking about specifically for the case of Cascais. Cascais municipality, I will present where it is for those who don't know where Cascais is. Cascais municipality has been actively engaged in both promotion of energy efficiency also and support innovative and sustainable solutions at the city scale. In terms of climate goals, Cascais is also part of the Covenant of Mayors, and they set a goal to reduce by at least 40% the greenhouse gas emissions by 2030. But of course, Cascais is really active in this matter, so for them is not enough, for the city is not enough. So they have also implemented climate action policy also in the adaptation sides. So if things get worse, they are already planning how to adapt to climate change. And also regarding mitigation, they are also aligned with national pledges that are really strong for the carbon neutrality plan. So the city has developed a carbon neutrality plan by 2052. And also in line with what are the national pledges regarding energy, the municipality is also developing the local energy strategy with a 10-year implementation periods that is in line with the national energy and climate plan. So this just to give you an overview of the energy and climate goals that the city is setting. In terms of the specific case study objectives, this case study aimed to analyze the optimal configuration of a heat supply network for both residential and service buildings, and also the technical economic viability of different scenarios of heat network, and also to identify the optimal coverage of the heat network and what are the cost-effective, efficient conditions. So the location of Cascais. So Cascais is located in Portugal, is located near the capital, that is Lisbon, that is more or less here, and is a relative medium-sized municipality with around 200,000 inhabitants. And the specific case study was located in Carcavelos, that is a parish of the Cascais municipality. So Cascais municipality is all of these, composed by 4 parishes. This was revised some years ago. And the case study is one of the region here that is close to the sea, and he is experiencing high urbanization rate, so the population living there is increasing. Also, I provided here two maps of Port in the right side, two maps that basically show the climatic zones in Portugal, just to show that Cascais is not located in the region with the highest necessity for heating, but more importantly for cooling. Nevertheless, this can be the case study. The importance of this kind of district heating is also relevant for the municipality to analyze what can be the optimal conditions for this kind of possibilities for availability of heat for the population. Here is the map that I developed under the THERMOS tool. So this region, Carcavelos Sul, is an urban area located in the south region of the Carcavelos parish, like I was saying. Is composed by residential and service buildings. This is really important because it gives insights and the conditions of buildings with mixed uses, so consequently mixed demands. And the area is around 47 hectares, so it's quite small, and has around 1,500 households and 2,500 citizens. This is important in terms of more technical conditions. The municipality provide me the shapefile. So I didn't use the default information on the THERMOS tool. This is quite relevant because I had really detailed information about the buildings that are located in this region. So, like you already know, and you already made in your case studies, the first stage is the characterization of the initial conditions in both demands and also supply sides. In terms of demands, so I identified and classify all the buildings to be part of the network. Like you say, you can classify them required, optional, or exclude buildings from the solution. And also, you need to characterize the energy demands. And in this case, I must mention that I used the previous version of the THERMOS tool. I know that now the tool has already additional features, and one more really important is the cooling demands. But at the time, I only characterized the heat demands, and it was based like default in the THERMOS tool by the heating degree days of the region. That is a really nice feature of the tool, because if this type of information and detailed information for heating demand for each of the building is really difficult to obtain, so the tool help the users providing this information. Just to point out what was the numbers involved in this case study. The region covers 77 buildings, and the majority were residential. I only set 22 as required and leave all the rest as optional. This was just a part of the conditions that I was implied. Also, the region has 8 commercial buildings and 2 that were classified as other. This means that the total energy demand for the region was 10 gigawatt hours, and again, the majority represented by the residential sector. One feature of the region that of the case study that is also relevant is that this region doesn't have industry facilities. That that I know that in other case studies is really important because it can easily is a supply option for the heat network. So here in this case, we didn't have it, so it limits the supply side options. Also, big consumers that are located in that region. That, for instance, there is a new university located in this region, but it was not considered because they already cover their heat necessities with other technologies. Also, the characterization of the initial condition on the supply side. Like I was saying, we don't have industry, so we didn't have the possibility to use heat from industries. So what we made, we added a new possibility for supply. In this case, combining heat and power plants supplied by natural gas with a maximum capacity of 10 megawatts with different parameters in terms of cost. I will not enter in detail, but you can see it here. Also, the associated emission factor with natural gas. And also, we made the connection of the supply facility with two possibilities to connect, because it was important to try to analyze which routes the model choose. Depending on the region or the buildings that the model choose to cover in terms of heat. Also, really important, we tested two scenarios with tariffs. So two prices for heats, and the two prices were obtained for public available information for the only company in Portugal that that owns or that supply heats on that owns a district heating network in Portugal, this Climate Pass. So we used two scenarios with prices from 2015 and 2018. This was just one of the prices is higher and the other one is lower, just to analyze what was the effect of this variability in terms of price, in terms of the configuration of the heat supply network. Other really important parameters were the technical economic parameters associated for pipelines. They were different in terms of depending on the roads or area characteristics, and in terms of hard and soft. This is also default information by the model, but this information were further aligned with other case studies at the time, granollers, and my public thanks for this information, and we align this information with their case study, because this is, and I will present, I will say it in next. This is really important parameters for the results of the model. Also, I included installation measures for walls, roof, and floors from a European project that's called Priority. In terms of results, after some difficulties in terms of the achieving optimal result because of some networks that were not totally linked, but in the end the results were quite good, and the model provided a solution for a network that was able to cover 34 buildings, and the interesting part was the 22 required, of course, but also the network covered 12 optional buildings. The majority of the buildings included in the solution were mixed use, residential and services, and the network covered 45% of the demands. And so this means that more than 46% of the buildings that was classified as optional were included in the solution. So like I was saying, that all optional buildings that are here in the figure in the dark gray were 12 buildings, and the more distance buildings from the heat supply source were not included, because this to include these buildings that are more here in the north part, will require additional pipeline, and so additional costs, and so the solution, the model didn't provide this solution. This is just a list of the characteristics of the network. I know that in this new version of the software, you have this more information and more organized. So, but basically, this is just the solution that we obtained from the software, the cost, the demand solution that I was talking about. But I will not enter in detail this because it's really specific. Also, the economic results of the model. But I want to present this figure because it is really relevant and it shows summarize the results. So basically, this is the cash flow of the heat network solution for the case study, and you can see here that this heat network only begins to be profitable after 29 years. So this is really difficult to try to convince an investor in terms of the profitability of this network. And this was only obtained when we defined the tariff cost higher. So this indicates that only with heat costs, higher heat costs, the solution is the heat network is profitable. Because you have also, this is important because also we have to invest, the project has to invest in the supply technology. So we don't have, again, we don't have industry heats that we can use. So in terms of conclusion, this was the first technical economic feasibility analysis of a heat supply network for Cascais and Carcavelos region. To point out that the optimization is really sensitive to key parameters. So the heat demand, the tariffs, the investment costs, also the generation technology that you defined, and the network costs, and also the type of buildings that is linked with the heat demand. I think this is the key parameters. Of course, there are other that are also important, but this, from my perspective and from my analysis, are the most determinants. So I think in terms of investment in information collection and information detail, I think it should focus on here. And also, I also advise to make scenarios and try different sensitivity analysis that if you can say like this, and tweak all these parameters in your case studies. So also for the case study, at the time we had limitation in terms of options for heat supply technologies, only natural gas or biomass. We didn't include biomass because of environmental sustainability issues and also economic sustainability issues. So Cascais is located in the is a really urban region with some agriculture, but we didn't consider biomass because of availability and cost of the resource. And this is not biomass power plants are not being considered at all in Portugal, although some centralized, but with different objectives. So again, there was a limitation in terms of allocation of energy demands, but the model offers, and offers the possibility of using really data. This, for me, this is really important because you have more robust capacity of the results that you obtain if you have real data in terms of heating demands. The high investment and return periods of the solution that the model provided, although look really difficult to convince from the key stakeholders, private stakeholders that we talked about during the duration of these projects, find it interesting. But so they see this tool as the first first layer of analysis of the possibility of heat and network in this region. Also, the model makes the possibility to analyzing circumstances of building renovation and retrofits, and also the potential use to reduce energy poverty conditions. So you can, and I didn't test it, but I wanted to test it if, and now you have the possibility to have different tariffs depending on the buildings. And I think this is really important because for the municipality perspective, they can approach district heating supply network as a possibility to provide heat to social housing or houses that have limited access to heat or cooling. So, okay, thank you. Obrigado.
Thank you, Luis, for this presentation. I would encourage everybody who has an immediate question to raise their hands if they want to be given a word or to post a question. I see there's one from Luisa. She's asking you, first of all, she thanks you for the presentation, and then she would like to know if the network was proposing heat and I don't know what that means. Can you spell it out for me?
District of the year the heat was required. I think. Yes. Okay. I think okay. And domestic hot water. Okay. First, the version of the software that I used at the time didn't have the really nice feature that is available now. That is the profile of demand. And so straightforward, I didn't enter in detail the variation across the seasons or the year in terms of heating and cooling at the time. But I think it's really important because you can define also tariffs, variable tariffs across the year, and can be really interesting for private investors in terms of supply. Again, domestic hot water. And to be totally honest, I didn't present in detail, but I only, like I said, I use the model default information for both demands in terms of heating, space heating and domestic hot water. I really intended to, limited time always, to make some assessments on the detailing heating demand, because there are already some studies at national level and that go at municipality level that provide detailed information in terms of heating demand for space cooling and also heating demand for water heating services. So yeah, I think it is a possibility, and I think it is really important to have this kind of information because it makes the assessment more robust. I don't know if there are more questions.
Is there more questions? Indeed. If not, I mean, we still have time at the end if you think of something. Otherwise, I have questions, Alex? Sorry, yes?
Yes, there are two questions. Sorry, in the chat I can read.
Them.
Yeah, so I think it's probably directed. Yeah. Okay. One question, Luis, is why you selected this location to do these assessments? And also the second one is how long did it take you to develop the case?
Okay, perfect. Really nice question. The location was selected 80% by the municipality and 20% by me. We articulated in terms of what are the interests of the region, and that region in particular, I didn't present the map, so I focused in the neighborhoods that. But in the south part of that region, there's the expectation of a new neighborhoods with also residential and also services, big neighborhoods. And the municipality also wanted to analyze a similarity in terms of neighborhoods for trying to study the viability of a heating network for this new region. So it was basically defined like this. There will be new projects, a new urbanization located in nearby. So make the analysis here. It was more or less like this. And like I said, it is an area that is really intense in terms of new construction. And time that I allocated to this. It took a little bit of time in terms of if you've tried the tool at the first stage, it is quite simple and quite quick to make some assessments. I think I took like 3 days, like 1 day to make the first assessment, and some errors. Part of the model at the time now is really being improved, and 1 day just to, of course, 1 hour just to try basic things, and then I increased the level of complexity. Try different prices, and then the solution didn't provide a result, so that the tool didn't provide a result. I contacted the forum. It was quite interesting. I exchanged some doubts with the developers. That's, I think you already present that there's a forum where you can put some difficulties that you are finding. So I was increasing the difficulty, the complexity of the model, and it took me around 3 days, I think, more or less.
Okay, perfect, Luis. Thank you very much.
Thank you. Daniela, do you have an additional question, or can we move on?
And no, probably we will have more questions at the end.
I start.
We are also going to mute everybody our microphones to hear you better. Thank you.
Okay, thank you. Well, this is my experience with THERMOS. It's a real case, but is the my 6 cases. I developed 6 cases between urban areas, industrial areas, and other cases for expansion and other kind of things. So this was a story about my stumble, but not false. I start with the presentation, and I try to be fast. Okay, here it is. Well, the first question is why to use it. Well, I start when I knew about THERMOS. I went to the website and I saw all these features, and I decided to try. But this is the feature. These are extracted from the website. So I find some more features friendly. So I decided to try. Why not to try? This is the question, the real question. So this is my experience. Well, this is not software for non-expert or for people who know how a district heating and cooling works, because you must to interpret the data. It's not for a beginner or something like that. You need to know how district heating works. You know what is the main route you have to construct, because it's very difficult from scratch to construct a district heating in a city, or you have to explore a solution inside, or if you don't have all the documentation, you must know something about the subject. Well, this was my first stumble. Well, the program only works in 70 HDD base temperature, so it's a good base, but for example, for Portugal and Spain, I think that other bases fits better. So I propose that you can choose other bases, because sometimes you are more familiar with other bases, or other bases fits better to your area. Well, the second was about the maps and network. They are really this feature is really easy to use. Well, contains some kind of bugs, but if you have some experience in district heating, it's very easy to fix them, because you can connect, you can create new paths, you can create new buildings. So it's easy, and it's not important. The Maxon network allows you to know high heating demand areas and other kind of important not cases, relevant information. Of course, it's useful to place the central heating station, because you have maybe several sites, and you can see, or you can try to set the center wherever you want in the map, and it's very easy, it's very friendly. So about the network and consumption, well, I have it's not a problem, because you can always complete the whole consumption with real data. You can mix real data with the assumption that the program makes. So it's very easy, but sometimes it's necessary to calibrate, because if you have real data in a few buildings, you can easily improve the accuracy of the result. You use a book methodology for the modification of the demand. So sometimes I have to work by hand, building by building, and sometimes was hard. Maybe with a new button is easier and faster. Well, about technologies. Well, we have it's not a problem. It's how the movie of Paul Newman, if you know, Kulhan look, what we here is a failure to communicate, because nowadays you need to use low carbon energies, because the district heating need the support of public entities. Public entities are public entities are aligned with the European regulations, so they push us to use low carbon energy. So maybe with biomass, other renewables, the solution, the cases will be more more attractive for public entities, and you need the support of the public entity in order to develop district heating, because it affects urban areas, public infrastructure, and all that kind of infrastructure. So I propose to have other kind of fuels related to this, other kind of emission, because for example here the CO2, we have to make a report every year about the emission of every district heating and cooling, and it's other kind of emission. So we need to a new input to determine or to input new emissions. About the solution summary, well, it's very completed. You can see the whole route with all the diameters. You have a simple business plan but you need to improve this plan, because you have to know how you are going to financial. You have maybe you have subsidies, or you have funds, or you have shareholders. So well, but you have the main feature you need to develop a new business plan. Well, the export of the tool now it's so. You can only print the screen, and sometimes it's difficult to to work in other program. But well, it's a good thing because you have the information, but you have to translate by hand. But this is the key. Now that you better have an idea of the subject, because if you don't know about the subject, it's impossible to interpret the whole information and the idea of the district heating. Well, this is my conclusion with 6 cases. This is well, this is this came, the core of this is a discussion with Juan, Paolo, and Julen sent me some email about how it could be. So this is the conclusion. Well, the tool, the energetic results are pretty accurate, but well, we need some kind of input in order to calibrate the tool, because sometimes you have real data, and as say, you can calibrate and have a more accurate solution. The economical results are not as precise as I know, but well, it's a kind of figure that you can work on. So if you have better, if you have the diameters, if you have the route, if you have the path, you can calculate substation, central stage, central power station, and other infrastructure that you're going to need. So it's a point to start. Well, of course, the tool is considered useful because you save time and money. With only a couple of hours, you have an idea of the feasibility of an area. You have to work hard, maybe several days to have the whole solution, but it's a good point to start. It's a great solution for a small or simple network because everything is automatic. So it's for 10 building and 5, 10, 15 building is very easy to use. For a complex network, you have to do a lot of version. I remember with a case in which I use more than 100 version because I have to change the I have to place the power station. I have to see the optimal route. I have to change some kind of building. I have to add real data. So it was a mix, but it's a powerful tool because it's allows you to simulate different approaches and comparison between different approaches. So it's in a couple of clicks you have different options. Well, and now that Christmas is coming, well, this is my letter. Well,
thank you very much.
Sorry, my letter was out.
The letter, yeah, we need to see your letter. Thank you very much. We are a little short of time, but we would like to. We have to give some minutes, some questions for Jorge, and also you have raised several issues that. As I said before, we have our technical team also here, so we would like to also answer to you. Specifically from the issue about needing more choice on the different fuels to include into the model, I would like to give the floor to Martin. Probably you can tell us a little how can we address this in the tool. Martin?
Yeah, hi everyone. If hopefully everyone can see me and hear me, if not see me. Yeah, thanks.
We can see and hear you.
Good. Thanks, Jorge. That was a really interesting presentation, and also from Luis before. Some really interesting points you brought up there, and we are aware of some of those, and we are working on some solutions to address those, to make it a sort of more robust, easier tool to use. But the point about fuels, you said about it could do with having more fuels as an option. You can actually add that. I think perhaps we could make that a bit more obvious, but under the supply side of things, when you're defining the supply, you can add in under the fuels, when you're doing the profile for the supply, you can add in different fuels, and you can add those fuels with prices and associated emissions. So you can define any fuel you want by calling it a name, whatever you want. It could be wood fuel, giving it a price and the associated emissions, and then it will automatically appear on the supply, the supply technologies page. So yeah, I think we should make that a bit more obvious. But yeah, just quickly on the other point, on the degree day point, yeah, we're doing further work on validation of that, and we are indeed seeing how the model that we produced, which was actually trained on 30,000 buildings in Copenhagen, how we then relate that to other locations with different climates, and how we can relate degree days to that, so that the user can input. So yeah, that's just to mention there. So, but I won't go on, because I think we're running out of time. But thanks for those.
Yeah. No, thank you very much.
I use the inputs of new fuels, but I think it's very important for something that doesn't know different fuels.
Yeah, definitely.
Thank you very much, Jorge. I think that these letters to this Christmas letter to the kings okay. is our work in the project THERMOS to make them real, and hopefully we will be able to address all these in the following months. We will be in touch. You are in touch with our team in Spain, also with Yule and myself. We are here open to help you in anything that we can. Thank you very much, Jorge. You've been of great value for us, and hopefully you are inspiring other trainers to develop more than one case, 6, 7 or more. Thank you very much.
Thank you all, and great job.
Setting the bar high. Actually, it's good that Martin already took the word, because I think it's time for Martin and Carsten. And it's time for our award ceremony, because of course we want to recognize your efforts and all the feedback you've given us and all the time you invested in testing the tool with us. And going through our exercises. So please bring on the ceremonial atmosphere.
Yes, please. In this regard, I think Martin was going to say a few words now as this is ending, of what will happen with the THERMOS tool. Some input from you, Martin.
Yeah, sure. So very briefly, yeah, amazing to think that we started this back in October 2016. Seems so long ago now. So much has happened in the world. But we're now 4 months left. Project finishes in March, the end of March next year. We were lucky enough to have 2 9-month extensions to the project. And the focus on the work in this last phase is, the technical focus is on validating the demand and the network and supply models, as I alluded to earlier with the demand. And then some other ongoing improvements to the user interface, and of course bug fixes. And we'll be producing a sort of final version in March. We're also, another thing we're doing is producing a new case studies publication, which I think some of you trainers might be involved in, the ones that are doing case studies, which should be really interesting. And the other thing is probably something you're very interested in, is what happens beyond the end of the project with regards to THERMOS and access to the tool. Well, we've been looking at producing a kind of business plan as a requirement actually under the project. And in this, we're looking at strategies about how we sustain the tool and move forward with it. And safe to say, you can rest assured that there'll be a sort of free version available for at least 3 years beyond the end of the project. But we'll also be producing a kind of what we call a premium version, because obviously we need some sort of revenue in order to keep things going once the project finishes. So that there'll be a premium version with some enhanced features for users that are able to pay for that. And yeah, we're having some ideas on developing the tool as well, and we're getting some of those from yourselves, the trainers, which is all really useful. But I think we need to find out a bit more about funding and what revenues might be, so that we can then see and plan to what extent we can go on developing the tool beyond March. So yeah, it's all quite exciting, coming to the end of the project now after so long, and working as a team with all the partners and colleagues for all this time. So yeah, it's good to see the end, good to see the final product. But when it's over, I'll certainly miss THERMOS as a project.
Well, I can only agree. I think end of March will be a bit of a mourning period for me, but